Hello everyone, welcome to Artistic Atom channel. I am Fatima and today we will be discussing materials and their structure chapter, which is a part of chemistry from Learner's Books Stage 7. And this is our session 1. So let's get started. So in this session, we'll be discussing the following points. Firstly, we'll be understanding what do you mean by the term matter. Nextly, we'll be understanding uh, to sort this matter into different states. Now, nextly, we will be understanding a particle model to understand these states very well. After we have learned the particle theory, we'll be learning the properties of all these states. Let's get started. Now, firstly, I want you all to look around you and observe the things and the objects that you have. You may have a chair on which you're sitting. You may have a pencil or a book, even your own self. What do you think all these things are made up of? Think for a minute and then try to answer it in the comment box. Now, these things are made up of nothing but a term called as matter. What do you understand by this term matter? Let's see. So, matter is nothing but anything that can have mass or which can occupy space. Or you can also define it as anything that you can see or it is called as matter. Now, this matter can exist in different states. For the time being, we'll be discussing only 3 states of matter, that is nothing but solids, liquids, and gases. There are more, but for your stage level, these are the only things we're going to discuss. Now, when we talk about liquids, you can see in this glass that liquid or the water that we have poured inside it has occupied some space. Even it has some mass. I can see it, I can feel it. Okay, so I will call this as what? Matter. And which state of matter is it? It is a liquid. Now, next we have this example. In this example, can you see in first class, I have poured some amount of water. Can you see a red line over here? This red line indicates the level of water. Now, as soon as I have added these 3 spheres, which are nothing but my solids, the water level has increased. What do you have understood from this? We have understood that the solids also occupy space. I can see this, they have mass, and I can feel it. This means it is also a matter. The next example that we have is of gases. So can you see here, initially I have put a balloon over a bottle, and inside that bottle there is nothing. That's why that balloon is deflated. Now, as soon as I have put it in hot water, there are water vapors that are created inside it. And because of which those gaseous molecules, they are creating a pressure and they are moving inside the balloon and making it to inflate. So from this, I have observed that inside this balloon, there are some gaseous molecules which has occupied space. Along with that, they have mass and also I can feel it. So this means gas is also matter. So this is how actually you will determine whether the provided thing is a matter or not. So in the universe, most of the things are matter because they occupy space, they have masses, even you can feel it. Now let's move to the next point. Before we move ahead to the properties, let's understand the particle theory. So before moving ahead to the particle theory, we should know what do you mean by the term theory in science. So the theory in science, whenever scientists are putting forth a theory in science, there are different steps that they're supposed to follow. So the first step of putting forth a theory is putting forth a hypothesis. Now, what is a hypothesis? Hypotheses are nothing but the suggestions or the ideations given by the scientist. Now, after these suggestions and ideations, scientists starts to carry out certain investigations. Or we can say some kind of laboratory experiments or certain procedures that they follow in order to prove their suggestions. So that procedure is called as investigation. Now, when these investigations are widely accepted and their validity are widely accepted by the scientists, different scientists, then the term those particular investigations as theory. So once their validations are given, scientists convert or name their investigations as theory. Now, in case of particle theory, why they have come up with the term particle theory? Because in order to explain the behavior of solids, liquids, and gases, the most important and the validated theory was particle model. Let's understand what is this particle model. So in particle model, scientists has considered all the different tiny molecules inside these states as the particles. Can you see in this figure, in case of solids, these are the particles which are quite tightly packed. They're not happily packed. And in case of liquids, they have a little bit of space and they are randomly arranged. But in case of gases, they have a lot more space in between them. This is nothing but a particle theory. But in order to explain particle theory in a more scientific way, let's understand the different terms that we should use. So, I want you all to observe these three pictures. So, the key point that you should remember in particle theory are nothing but, first, whenever you are showing the molecules inside the solid, liquid, and gases, make sure to either use spheres or circles. So these spheres and circles are nothing but the particle inside that particular state. So matter is always made up of tiny particles to which we will be using a circle or a sphere to represent. Nextly, the second point that we should remember is that always these particles, they keep on vibrating. Now, even in case of solids, liquids, and gases, the particles, they keep on vibrating. But they only move depending upon the state in which they exist. Like for example, in case of solids, particles vibrate but they do not move. Why? The reason behind that is because they are tightly packed. And since they are tightly packed, there is not enough space for them to move. Whereas in case of liquids, they have a little bit of space, so along with vibration, they can move. But in case of gases, they have a lot more space between these particles and hence they can vibrate and move too. The third point that we should remember is that these particles, they have a space between them. Now that space is called as intermolecular space. So you should use the term intermolecular space every time whenever you are trying to explain about the space between these particles. Now the last point that we should know that even if these particles, they are far apart in case of gases and a little bit of space less than that of gases in case of liquid, even in case of solids, these particles, they always attract each other. So these are the important points that we should remember whenever we are trying to apply particle theory to any solid, liquid or gas substance. Now nextly, we will be moving ahead to the properties of solids, liquids and gases. So when we talk about the properties of solids, liquids, and gases, these are the following criteria that we are looking upon. So the first criteria is shape. Now in this figure, as you can see, in case of solids, since the particles are very close to each other and there is not enough intermolecular spaces, they are tightly packed. And since they are tightly packed, they have a fixed shape. Even you can see from a beaker when we have poured it. When we have poured it, still it has the fixed shape as it was having inside the beaker. Now nextly we can see when we are talking about liquids, since the molecules, they have a bit of intermolecular space between them, they can take the shape of the container. Now as you can see from this cylindrical beaker, as I'm pouring it on the flat surface, it is starting to take the space exactly like the flat surface. So this means liquids takes the shape of container and they do not have a fixed shape. Yes, so they take the shape of the container in which they are kept. Now nextly, when we talk about the gases, they can occupy the space whatever they have in their surrounding. Like for example, if I have poured the gas inside the cylinder, it is coming out and emerging out and occupying the rest of the space that it has. So I cannot make out the exact figure with which I can describe its volume or its shape. So they do not have a fixed shape. I cannot say that gases are rectangular in shape, gases are triangular in shape. So the conclusion is gases do not have a fixed shape. Now, let's move to the term intermolecular spaces. So, as we have discussed it previously, intermolecular space is nothing but the space between the particles. As you can see in the figure, these particles, they do not have enough space between them. So, in case of solids, the intermolecular space is very less, but the intermolecular forces are very strong. Inter means between, and molecular means molecules. So between these molecules, the forces are very strong. Hence, they are tightly packed. But when we talk about liquids, the intermolecular forces are a little bit less than that of solids, due to which particles can move around. Now, when we talk about gases, intermolecular forces are a lot more than that of liquids and solids. Hence, they can move freely anywhere. Now, the next property that we'll be discussing is whether liquids, solids, and gases can be poured or not. So, as we have discussed, solids, since they have very tightly packed structure, they cannot be poured. In case of liquids, since they have a little bit of intermolecular spaces, they can float upon each other and can be poured. And in case of gases, since they are much far apart than that of liquids, they can be easily poured. Nextly, the property is volume. So when we talk about volume, in case of solids, we know that they have fixed volume. Yes, I know that this particular solid is going to take up this much space in my container. Even along with liquid, we can say that they have fixed volume. Why? Because if I pour a bottle of water inside a beaker, I know that how much water I have poured inside that beaker. So I know the volume of the liquid. But in case of gases, since they occupy uh, whatever space is available in their surrounding, I cannot make out the exact volume of the gas that I have poured. Like for example, in a cylinder, I was having 100 ml of gas. Now I have poured it into a glass. Now since the glass has an open opening, the molecules have started escaping from the beaker and they're trying to occupy whatever is the space in the surrounding. And since they're occupying that space, I cannot make out how much volume exactly they have occupied in the beaker, because some gas particles may have, uh, you know, uh, uh, exited from the beaker. So I'm not sure of the exact volume of those gas particles. Now next, when we talk about the flow. So we know since solids are tightly packed, they cannot flow easily. Whereas in case of liquids, since they have intermolecular spaces, they can easily flow. And in case of gases, yes, they also have intermolecular spaces, so they can also flow. Now the next property is the compressibility. So when we talk about solids, so in case of solids, we know that these solids cannot be compressed. Why? The reason behind them is their strong intermolecular forces, the way they are tightly packed inside each other. So I can see in the first syringe, I have added a chalk powder, which is nothing but a solid. So all the particles are tightly packed. So even if I'm compressing it using a plunger, I cannot see any change in the space compared to the initial one or the initial stage. Now, in case of liquid, I can see that I have poured a liquid, and when I'm compressing it using a plunger, the plunger is not going inside. But I can see that yes, there is a small difference compared to the initial one, because initially it was here. And now, in case of liquid, when I have compressed it, it has compressed to a certain extent, but not much. So we can say that in case of liquids, they are compressible, but to a slight extent. It is so small that we clearly neglect it, and we say that the liquids are not compressible. But in case of gases, as you can see, the plunger is completely compressed, so we can say that gases are compressible. Okay. Now, next property is the particle movement. So when we talk about the particle movement, we know that in case of solids, particles only vibrate in their fixed position. They do not move. Whereas in case of liquids, particles vibrate and move too. Why? Because they have more intermolecular spaces, more space available for them to move. Now, when we talk about gases, they have a lot more space available between these particles, so they can move easily and they can space themselves randomly. Now, the next thing that students face a difficulty with is the trick. Remember all these properties, because when I come back to this table, I can see that in the table I was having solids, liquids, and gases. Now, when I'm talking about solids, liquids, and gases, I remember that I have to discuss these states. But what are the all properties that I'm supposed to discuss? Or the properties with which they differ with each other. So in order to remember all the initial terms of those properties, we use this acronym, which is nothing but SPCFMI. So if you remember this, it's easy for you to remember the criteria with which they differ. So let's understand how to use this trick. So SVCMI. So S stands for the shape. So whenever you're talking about solids, liquids, and gases, make sure to discuss about the shape. So I know in case of solids, the shape is fixed. In case of liquids, they take the shape of the container, but in case of gases, the shape is not fixed. When we talk about volume, as we have discussed in the table, you can refer to it. And then we can also discuss about the compressibility, because with these acronyms, I remember the criteria with which I can exactly distinguish between all three states. So C stands for the compressibility, F stands for the flow, M stands for the movement, and I stands for the intermolecular forces. Isn't it easy to remember using this trick how to distinguish between the different properties of these solids, liquids, and gases? Now, sometimes what happens, it happens with me actually, that sometimes I'm not able to, recall what was the exact property of compressibility and volume for solids, liquids, and gases. Because for others, yes, I can make out from the initial point only that the particles, they do not have enough space between them in case of solids. But in case of gases, they have space. This means they can move easily. But in case of gases, they have a lot of space. So, but when it comes to compressibility and volume, it becomes difficult for me to remember what was the exact property. So for that, this is the acronym that you can use, SLG. S stands for solid, liquid, and gas. When we talk about solids, they are stubborn. So stubborn means they do not change volume. And as they are stubborn, they do not even compress. Nextly, when we talk about liquids, they are loose slightly. So when I say the term loose slightly, it means the volume is mostly fixed, like slightly change in volume, but not more. So that's why we just ignore that change and say that they have fixed volume. And even they are slightly compressible, but still we ignore that point and we say that they are not compressible. And gases, they are good, like they have their own fun and they can move anywhere. This means the volumes easily changes, and also they can easily be compressed. So this is how you can remember the property of compressibility and volume for all these three states. I hope you enjoyed the session, and let's see you in the next session. So please comment your uh, questions or whatever doubts you have in the comment box. And please like, share, and subscribe to my channel, Artistic Atom. And see you in the next session.